Welcome to College Algebra, Math 1314. For this recording, we are going to be solving composite functions, and in this case, we are going to evaluate f of g of x and find the domain of f of g. Now, please remember that f of g of x, its definition is basically asking you to put one function into the other. Now, I'm first going to input my g of x function, which is 8 over x, into every x that I see in my f function. So f of 8 over x, I have 5 over 8 over x plus 4. Now, due to the fact that I have a fraction within a fraction, I'm going to go ahead and multiply everything by this denominator to help me get rid of it, of the fraction within the fraction. So I'm going to multiply by x. Now I need to multiply everything else by x. So you need to multiply all your terms. So 5 times x is going to give me 5x. And this is going to cancel out. So I'm going to have 8 plus 4x. So f of g of x is 5x all over 8 plus 4x. Now, the second part of the problem asks to find the domain of f of g. To find the domain of f of g, you need to find the domain of the inside function, and in this case, it's the g function first. So the domain of g of x is equal to 8 over x. I cannot let x equal 0 because that would be a 0 in the denominator. So, for g of x, domain x cannot equal 0. Since we already performed the composite and this was our answer for the composite, then you need to now find the domain of your answer from the composite. So I'm going to set the denominator equal to 0 to find out what x is equal to. 8 plus 4x is equal to 0. I'm going to subtract 8 on both sides. And then divide by 4. X is equal to -2. Now the reason why I put not equal to is because we cannot let x equal -2, as that would give us 0 in the denominator. Now, the domain of f of g of x is x cannot equal -2. To find the domain of the composite function, you need to combine the domain of the inside function along with your composite function. So x cannot equal 0 and also x cannot equal -2. So the domain of f of g entirely of x is x cannot equal 0, x cannot equal -2. When you're writing that in interval notation, I'm going to go from -infinity to -2, not inclusive, between 0 and -2, and from 0 to +infinity.